Distance and midpoint formulas. Now let's find a formula for the distance between 2 points. All right, so we have our 2 points are A, which is at x1, y1, and B, which is at x2, y2 in the plane. Recall that the distance between points on a number line is just the difference in the value. So if we look at this point C here, there we go. Eventually we could write. All right. So if we look at point C there, the distance between A and C is just the difference in the x coordinates. Right. So the distance is always positive. That's why the absolute value bars are there. So we don't get a negative number. Right? Because I could also do this. And so long as I have the absolute value bars, I'm going to have a positive number. All right, so now if we look at the vertical distance, right, because there's both a horizontal and a vertical distance to get from point A to point B, we could represent that vertical distance as the distance between B and C. All right, so notice here the x-coordinates aren't changing at all between B and C, just the y-coordinates. And again, distance is positive, so we take the absolute value to find the length, the distance between points B and C, or the length of that segment connecting points B and C. And so now, but if we want to find the distance between points A and B, we have to take into consideration the horizontal distance, and we have to take into consideration the vertical distance. If we take into consideration the horizontal distance, we have x1 and the absolute value of x1 minus x2. If we take into consideration the vertical distance, right, then we have y1 minus the absolute value of y1 minus y2. Now perhaps though we don't want to have the absolute value bars, but we want a way to make sure that they're still going to be positive. Well, if we square a number, it's always positive. Right, so we dropped the absolute value bars and we squared the difference between the x-coordinates and the difference between the y-coordinates. But you just can't go squaring numbers. You're going to change the value. But we can square if we undo what we did by taking the square root. So if we take the square root of x1 minus x2 squared and plus y1 minus y2 squared, we have the distance formula for finding the distance between any 2 points in the coordinate plane. You can also think of this as Pythagorean theorem. Right? So if we have a right triangle here, right, because we have a vertical and a horizontal line, if I take x1 minus x2 squared, right, that's one length of the triangle, and y2 minus y1 squared, that's the other length of the triangle squared, and add those together, we would have, let's call that d, right, because it has d here for distance, we would have the distance squared. And how would we solve for d? Well, we would simply take the square root of both of those. And you see that's exactly what the distance formula is. If we took the square root of x1 minus x2 squared plus y2 minus y1 squared and the square root of d squared, we would have exactly what we have right here, the distance formula. Right? So it's really easy to find the distance between any 2 points in the coordinate plane using the distance formula. And basically you have what we just said on the other page summed up on the top there. So the distance between 2 points, A, x1, y1, and B, x2, y2 in a plane, is just the difference in the square root of the difference in the x-coordinate squared plus the difference in the y-coordinate squared. So now that we've gone through what the distance formula is, let's answer our question here. Which of the points, 1, -2, or 8, 9, is closer to the point A, which is at 5, 3? So in other words, we want to find the distance of AP and the distance of AQ. Right? The distance between points A and P and A and Q. Right? So it doesn't really matter which point is which, right? This one can be the x2, x1, x2, y2 for the first part of the problem, and you can be the x2, y2 for the second part of the problem, and you'll just be x1, y1. Right? Because we're finding the difference between in the first example, we're finding the length of AP, so we're going to use points A and P. In the second one, we're finding the length of AQ, so we're going to use points A and Q. All right, so we have 1 minus 5 squared, the difference in the x-coordinates squared, and the difference in the y-coordinates squared. So that's negative 2 squared, negative 2, not squared yet. I really want to square, I guess. Negative 2 minus 3 squared. All right, so that's going to be negative 4 squared plus negative 5 squared. Remember, you're squaring the whole thing, not negative included. All right, so this is going to be a positive value. So this will be the square root of 16 plus 25, which I didn't, let me give myself a little, you know what, I'll just put it over here, which is equal to the square root of 41. That doesn't simplify at all because that is a prime number. Let's now find the length of AQ, and I'm just going to switch colors just to make it stand out. All right, so now we find the difference between the x-coordinates between A and Q and the y-coordinates between A and Q. So we have 8 minus 5 squared plus 9 minus 3 squared. So 8 minus 5 is 3 squared. 9 minus 6 is 6 squared. That would give us 9 plus 36, which is equal to the square root of 45. By the way, that does simplify. It's a good idea to go over it. So 45 is 9 times 5. 9 is 3 times 3. We've got a pair of 3, so 1 3 comes out, 1 3 goes away. Simplified, this is 3 square roots of 5. Which one is closer? Well, the square root of 41 is less than the square root of 45. So the segment AP is less than the segment AQ. So therefore, point P is closer to point A than closer to point A. Let's end our sentence there. All right, so since that segment AP is shorter than segment AQ, point P has got to be closer to point A than point Q is. Actually, I'll add that part, than point Q is. All right, and so a little work with the distance formula. All right, so I'm going to pause this tape, and then we're going to look at the midpoint formula.